As we head into the cooler months, many of us start wondering what kind of winter is in store. Will it be mild and rainy or heavy snow or bone-chilling cold? To find the clues, meteorologists like me often look thousands of miles away to a vast, remote region in northern Asia, Siberia. It might seem strange that a place so distant could have such a big impact on whether you will need a snow shovel in Chicago or an extra warm coat in London, but it is one of the most reliable signals we have for long-range winter forecasting. This massive expanse of land acts like a giant natural refrigerator for the northern hemisphere, and the amount of snow it accumulates each autumn can set the stage for our weather patterns all winter long. The story begins in October, a critical month for this forecast. The resulting snow cover acts like a giant mirror, reflecting sunlight back into space instead of allowing the ground to absorb that heat. That reflection dramatically accelerates cooling of the air above, creating a massive dome of very cold, dense air, the Siberian high. It quickly becomes a major player in the global weather game, influencing the strength of the polar vortex and shifting the path of the jet stream. So, Siberia's snowpack is the birth of an atmospheric driver that sends ripples across the globe, a butterfly effect on a continental scale. When we use the term snowpack, we are talking about more than a single snowfall. A snowpack is the total accumulation of snow piled on the ground over time, a layered blanket that grows thicker with each storm. In Siberia, where freezing temperatures persist for months, the snowpack can become incredibly deep and extensive, covering an area larger than the entire United States. The deeper and more widespread the snowpack, the more it cools the air above it. Measuring the snowpack combines old-school techniques and modern technology, driving a pole to measure depth and collecting core samples to calculate snow water equivalent, SWE. SWE tells us how much water would remain if the snow melted. From above, satellites are our eyes in the sky. Visible images show snow extent, while microwave sensors estimate depth and water content even through clouds. Combining these sources yields detailed daily maps. Tracking snow cover extent in October is the cornerstone of long-range forecasting. We are watching a trend. Is snow advancing faster or slower than average? Covering more area than last year and than 5 years ago? Autumn snow accumulation in Siberia is a powerful early warning signal for the coming winter. A vast white snowpack reflects a huge amount of solar energy back into space, a concept known as albedo. By reflecting sunlight, it keeps the ground and the air above it exceptionally cold, creating the Siberian high. The Siberian high actively reshapes the atmospheric landscape, like a giant boulder in a river disrupting the normal flow of air. The polar jet stream is a high-altitude ribbon of wind. Its position determines storm tracks and whether your region is cold or mild. Extensive snow makes the Siberian high bulge northward, forcing the jet to buckle and become wavier. Those deep troughs open the door for Arctic air to pour southward. Imagine the jet stream as a fence holding back a pack of dogs. The cold air. A strong Siberian high can knock down a section of that fence, letting the dogs run into new areas. This disruption can lock in for weeks or months. The reinforced Siberian high influences the stratospheric polar vortex. It can weaken, stretch, or even split into pieces. Snow accumulating in Siberia sets off a chain reaction that can bring a frigid Siberian express to your doorstep. Let us dive a little deeper into the polar vortex. It is not a storm, but rather a large-scale circulation of very cold air that consistently spins over the polar regions, high up in the stratosphere, about 10 to 30 miles above the surface. When the polar vortex is strong and stable, it keeps the coldest air tightly contained over the Arctic, often yielding milder mid-latitude winters. The connection to Siberian snow comes from how it energizes the atmosphere. Think of it like striking a massive drum. The vibrations travel upward into the stratosphere and can disrupt the vortex. They effectively push on it and knock it off balance, weakened, elongated, or split. When pieces break off, intensely cold air can be displaced southward, causing prolonged, severe cold outbreaks in North America and Eurasia. This is often dubbed the Siberian Express or polar plunge, a wholesale replacement of the existing air mass with one straight from the freezer. Some of our most memorable winters are not about a series of quick storms, but long stretches of bitter, unrelenting cold. A rapid October snow growth acts as a precursor. It raises the odds that the polar vortex becomes unstable later, increasing chances of a Siberian Express. Taken together, the physics are clear. grow the snow, build the high, bend the jet, and you raise the risk of significant cold intrusions. So what is the data saying right now for 2025 to 2026? As of late September 2025, the initial data coming in from Siberia is painting a compelling picture for the upcoming winter. Satellites show a notably rapid advance for this time of year. Compared to the long-term average, the snowline has pushed farther south at a quicker pace than we have seen in several years. Current extent is significantly above the historical median, and models suggest the trend will continue, even accelerate, into October. A more extensive snowpack boosts albedo and supports a more robust Siberian high. The engine driving the pattern changes. Based on this strong early signal, the preliminary outlook for the 2025 to 2026 winter leans colder and more volatile for large portions of North America and Europe. Rapid snow growth favors a negative Arctic oscillation and a weaker, wavier jet, a setup notorious for delivering cold air outbreaks. For North America, a strong Siberian signal often plays out as a tale of two coasts, with a persistent trough digging over the central and eastern U.S. This acts as a superhighway for Arctic air, with cities like Chicago, New York, and Boston facing more frequent and severe cold snaps. Snow potential increases, especially around the Great Lakes in the Northeast during suppressed southern storm tracks. Meanwhile, the West often sees a strong ridge that blocks Pacific storms, favoring drier, milder conditions. That can spell trouble for mountain snowpack and water supply heading into 2026. In Europe, a Scandinavian block can deflect Atlantic storms, opening the door for Siberian air to sweep west. The classic beast from the east setup. Northern and Central Europe risk prolonged cold and heavy snow, even sea effect bursts along the North Sea, while Southern Europe trends milder and wetter with increased flood and landslide risk. Expect higher heating demand in the north and potential travel disruptions, while the south contends with more storms and high-impact rain. This is a seasonal outlook, not a daily forecast. There will be mild periods, but the deck is stacked toward more frequent and intense Arctic blasts and persistent patterns. Recent history shows the stakes. In 2012 to 2013, a record-rapid Siberian snow advance preceded a severe European winter, and a March beast from the east. In 2013 to 2014, a strong Siberian signal preceded prolonged Arctic outbreaks in the United States and record Great Lakes ice. Conversely, slow autumn snow growth tends to keep the vortex strong and winters milder, as in 2019 to 2020. Given 2025's early signal, eastern and central U.S. and northern Europe should prepare for cold air outbreaks. Ensure heating systems work, insulation is adequate, keep a winter car kit, and stay alert to local forecasts. Businesses should review contingencies. Farms and energy planners can leverage this early warning. In the West, drier, milder conditions elevate water supply concerns. In southern Europe, wetter storms raise flood risks. Ultimately, watching the Siberian snowpack is a powerful tool that gives us a head start. As we monitor the data through October, the message from the snows of Siberia is loud and clear. Get ready, because this winter has the potential to be a memorable one.